You're listening to the Chorus One podcast, a show that covers decentralized networks and their impact on the evolution of automated and borderless economies. On this podcast, we invite pioneers and builders to discuss the decentralized protocols and projects they are working on. So hello everyone, welcome back to the Chorus One podcast, where I'm hosting today with Felix Lutsch, our Chief Commercial Officer. I've also got Oak and David here from Autonolas. So really excited to have these guys on the show. We've known Oak especially for a long time, and we've been meaning to get him on the podcast for a while now. Essentially, Autonolas is building the autonomous in decentralized autonomous organizations. So I'll leave it up to Oak and David to perhaps elaborate. And welcome to the show, guys.
Thanks for having us.
Thanks for having us. Yeah.
So I guess we'll dive straight into it. I guess the first question on our end would be great to hear from you. What is Autonolas?
Yeah, perfect. I mean, you've given a great introduction. So we have that vision of becoming the premier enabler of the autonomy in decentralized autonomous organizations, or somewhat cheekily, we make DAOs autonomous again. So what this means is we want to enable every DAO out there to put an autonomous software service at the heart of their off-chain operations. The way we do this is by offering them, one, a software stack that lets them build these off-chain services, and then two, an on-chain protocol to secure them. So the way to think about the stack is maybe to kind of have something like Cosmos SDK in mind. So it's a general purpose open source stack to build these off-chain services. It lets the developer implement the business logic for that logically centralized application, but then that can be run as a distributed system. We'll dive into what that means later. And then the protocol is there to sit on various blockchains. So it secures the service on the chain on which the DAO is actually operating. And the protocol we offer also offers some model of incentivizing effectively these services and the developers who contribute to them. And a bit what we also do is we build some of those services ourselves. So that's mostly for demo purposes and also to basically help those DAOs get going.
Awesome. Thanks for that. I guess one question also in terms of your two guys' background, how did you end up working on Autonolas, and maybe, what led you to crypto and this path? Maybe Oak can start.
Sure. Yeah. So myself and David Minarsch and a third fellow called David Galindo are the co-founders of Valerie, which is the company behind Autonolas. I am myself heading up sort of ecosystem and community. I have 10 years of experience in product roles in Web2 startups. And basically, I became somewhat of a degen DeFi investor in the 2017, 2018 timeframe. And along the way, kind of fell in love with the vision of autonomous agents and truly autonomous organizations. And basically that led me quite naturally to the two Davids, and we conjured the plan, which we're about to tell you about.
Yeah, nice. From Oak said a lot. I think my journey into crypto more generally was sort of this general interest in decentralized ledger and blockchain, sort of an interest on the software side in machine learning, multi-agent systems, and then a professional background. I'd done a PhD in game theory, and so kind of it seemed like the perfect merge of three topics, and I kind of got into it. Initially worked in various places, got into building multi-agent systems frameworks, and then eventually wanted to get back to my entrepreneurial roots and try myself. And with Oak and the other David, we kind of came up with what we think is a missing puzzle piece in what's out there to kind of deliver this true autonomy, which I think we haven't really seen yet in the way in which we think about it.
So we've said the word autonomy quite a lot, and we've sort of touched a bit upon how it might be useful for DAOs. So it'd be great to hear on your end how you would classify Autonolas. So would it be DAO tooling or middleware, or does it compare to anything else that's already out there?
So the way that we classify what Autonolas kind of generates is as autonomous services. So autonomous in the sense of being sort of self-executing, minimal humans in the loop, essentially. And then services is sort of code that's sort of long running and runs off chain. It's useful, though, to contrast this with DAO tooling and middleware. So with DAO tooling, generally what we found is that the focus is on helping groups of people work better on the internet together. That seems to underline it. But what we do is we really enable DAOs to create and own their own operations, operations which run as machine, they're machine run and don't require any humans in the loop. So it's quite a different vision of DAOs in a way. And then to contrast us to middleware, a lot of middleware out there is quite single purpose and relatively closed. So single purpose in the sense that, a particular piece of middleware tends to do one thing, be it oracles or bridges. There's really no way to kind of compose them into higher order applications. And middleware often also tends to be closed in the sense that it's often quite permission full to actually build. So with us, devs can essentially permissionlessly build any kind of autonomous software service, incentivized and coordinated by a protocol. And also we have this different emphasis in that we help DAOs essentially own and make their operations autonomous, rather than just trying to make it better, the sort of humans who are operating the DAO to kind of work better together.
Oh, sorry. I think it's super interesting, I guess, also as a DAO participant myself, or like in a wider sense, and just seeing, what you're saying. A lot of the tooling usually is about kind of helping to move the incentives across chain, I'm assuming, or things like that, right? Distributing it the right way, just vote execution. I guess that's kind of where you tackle. And then it's this generic framework to do that. You also mentioned you are building some use cases yourself. So I guess, right, the idea is there's going to be this SDK that you can use, and then there's some initial things that you are building. Like, what are those that you are building initially, just so people maybe get an idea what would be possible with your system?
Yeah, for sure. So maybe it's worth talking a little bit about our go-to-market, what sort of applications we have under Works, and how we're actually going to bring this kind of into its full fruition. David mentioned earlier that the project basically kind of breaks down into these three parts. One, which is services, these autonomous services. The other, which is the stack, which developers actually use to build these services. And then there's the protocol, which kind of pulls it all together and coordinates. So in terms of services, the go-to-market is relatively sort of do things which don't scale at the beginning, where we work directly with external teams, either for them to consume what we've already built in-house, or to assist them in building their own. So we've built a few apps. One is an Oracle, which can be directly imported into any kind of off-chain service which people want to create. We also have something which we call the El Collector, which is an autonomous NFT collector, which is sort of like a fun thing to, generally quite useful. But basically what it does is it waits for drops on art blocks and kind of has a decision-making tree which goes out and sets a good price and basically like acquires a bunch of NFTs autonomously. And one of the big benefits there is that it gives access to people who, one, don't sit around and wait for the drops to actually happen, but also enables them to get in at a price that they can afford. So that's the second one, and the third one is the beginnings of a yield or treasury management service, which essentially lets DAOs get put to work their assets in a more in a way that doesn't involve either a holdout vote or regular repetitive holdout votes, or individual sub DAOs, which are obviously trustful. So that's on the services side. On the stack side, basically we have something called the Agent Developer Academy, which sort of handholds Python developers through the process of building their first applications. And actually, El Collector came largely through the academy. That's been a great success so far. We can go into a lot more detail. I'm sure there are members of the audience who would be good candidates for it, actually. So yeah, would be keen to talk a little bit about it more later on. But then there's obviously also the protocol, and the plan for the protocol is to target a summer release. We'll be starting with what we call island deployments, which are kind of simple deployments on various chains, which don't require actually having a protocol in place. They just implement kind of an isolated example of one of these services. And yeah, basically we are chain agnostic, but we'll have an initial focus on EVM chains due to the kind of network effects there and the internal familiarity amongst a lot of other reasons. But yeah, it's worth noting that we're ultimately chain and kind of environment agnostic in the sense that ultimately we could have deployments on Cosmos SDK chains, on Solana or whatever. So yeah, we essentially have different go-to-markets for the different parts of our project, but that's an overview.
Cool, yeah, and congrats on already getting the first cohort with a service. That sounds incredibly useful, I guess, for many different people in the ecosystem. For sure, we'll get onto that later down in the podcast. And so we've talked a lot about these different sort of services that Autonolas can provide. So how are you providing these services? So in your website, and also from speaking before, there's something you call a multi-agent system that I'm not sure many people in crypto would be familiar with. So what is a multi-agent system? Is it using data to make these decisions and run these sort of services, or how does all of that work, and maybe how does that compare to what we have today?
Yeah, I love that question, and it's sure is an important question to clarify that. So let me try. So I think the first thing to note is that essentially a multi-agent system is essentially a computerized system composed of multiple parts, which we call the agents. And the agents usually have some level of intelligence, and more exactly we can describe them as sort of software that perceive its environment, i.e. other agents or other servers or other blockchains, whatever, then takes action autonomously, i.e. self-driven, in order to achieve some prescribed goals. And the interesting thing is that as you build better and better such systems, they should hopefully also be capable of improving themselves along the way. So that could be achieved by involving some forms of machine learning or reinforcement learning in the agent design itself. So we have the system made up of these agents. And one of the core characteristics is, or some of the core characteristics actually heavily overlap with blockchain, because in a sense, a blockchain is a multi-agent system. So one of the core characteristics is decentralization. So no agent itself is sort of usually progressing the objective. So the agents act independently, and then there's a sort of emergent outcome from their actions. Then we have this concept of local information. So the agents are usually there's usually no global view of things that can be obtained, and we'll get to that in a second. But the primitive is that every agent has sort of their own information set, and then the autonomy, which is the key thing, where in a sense it differentiates itself from a blockchain as such, because if you think about what happens on a smart contract layer on a blockchain, it doesn't really have autonomy, because it always relies on this external input in the form of a transaction in order to make progress, so to speak, in order to awake the autonomy and then execute some routine and then sleep again. Now, the benefit of having an agent which continuously runs off the blockchain is that it can continuously take actions, right? And so that is a much purer form in a sense of what we might consider a autonomous system, i.e. a system which is free to act independently and has proactivity. So that's on this multi-agent systems piece. And I'm happy to tell you more about how that kind of finds adoption or application in our stack.
Yeah, I think there's actually one immediate question I have from that. So we've talked a little bit about the protocol that you have. So how flexible is this protocol? So for example, if I am a shadowy supercoder and I'd like to run my own agents in these different systems to, like you said, make continuous transactions instead of having to go in manually at the start, will it be more like you have templates, or is there also the option for me as someone that is very good at programming to create my own agents?
Yeah, great question again. I think that it's important to come back as to, well, the short answer is there's complete freedom, and then let's come back at what we're trying to enable here primarily, which is this creation of services. And I want to pick this apart first before I come back to answer it further, the question. So the way we think about a service is that it's not a single agent, right? So a service is made up of multiple agents, and they collectively implement effectively what ends up being a logically centralized application. So if you have, let's say, a bot or a script which implements whatever it implements, a certain routine, then the idea is that you can also implement that on our service, but it's run as a distributed system. And the reason why you might want to do this, we can pick apart the exact benefits, but the core reason is that you effectively get a more robust system because there's inbuilt fault tolerance. You get a system which you can operate in a decentralized way because the different agents can be operated by different entities. And you get a system which is more transparent, because if I have a system which is effectively operated as such as described, then each of the entities needs to run the same code for it to work. And that makes these off-chain operations much more transparent than if I was, let's say, a single bot operator. So coming back to the developer you were mentioning, the way that practically would work for them is that we have effectively a framework on which you can develop these kind of services. And that framework allows you to build what effectively looks like a single agent. You implement all the business logic there, and then you can run it as many agents as you please. So that's mostly then a matter of the configuration, although it does have implications for the development process in which we kind of guide the developer. So that shadowy supercoder could basically go to our stack, implement whatever logic they want, and then either run it themselves still as a bot, or run it with their mates as one of our services. Implement these DAO operations on them, whatever they are. So I think that kind of answers your question, but we probably want to dive into elements of that because it was probably a lot.
Yeah, for sure. I guess one thing that immediately comes to mind, I think you just mentioned it at the end too, that you can also run it on your own, like as a bot. Because I guess like one thing that I was wondering here is, let's say I have some agent, something I want to do that is kind of, let's say, in the realm of MEV, right? I have some strategy that yields me a profit. I would now probably run it on my own because I also don't want to share it, right? I want to be the one that profits from it. Now, is Autonolas kind of helping that use case, or is that not something you're tackling? Because I guess maybe these people don't want to open source their strategies, or can you also leverage Autonolas in such a scenario? I guess that would be the question.
Yeah, it's a great question. I think MEV, which depends on mostly speed and insights, is probably not a use case for our stack at this point in time. I think forms of MEV where access to liquidity matters in some form, you potentially don't mind where robustness is more important. Forms of liquidations, let's say, although it's arguable whether they MEV still, they're much more natural for this, because effectively, whenever I want to have the guarantee that the system is actually available rather than that it's necessarily private, then or hidden from view of others, then such a service is much more desirable. And I think that's exactly why we are so focused on DAO operations, because there you have these particular needs. So let's kind of directly relate the three properties I mentioned. Robustness, that's an operational concern, right? Whenever I want to operate something, I want to be sure that it's actually there when it's needed to be there, then robustness becomes a requirement. And what you can do on our stack is you can run that business logic you've implemented as a coder to run, let's say, with 4 agents, and then you have a redundancy of 1 agent being effectively down or unavailable, or even malicious. Now, the second point, transparency, is a concern around auditability, right? So if I'm a DAO and I have a certain amount of operations which happen off-chain by nature, then it's kind of intransparent at the moment for the other members of the DAO to exactly see what's going on. There's a lot of trustfulness there. And so by encoding this into software and making it openly available and making clear who the operators, and I gain transparency and auditability. And then the third point, and I think that's one of the most missed points, I think, in as we talk about DAOs at the moment, is liability concerns. So if I'm a member of a DAO and I am actually operating some script or bot, I am much more interested for some parties which want to enforce whatever they want to enforce, like on the regulatory side. They're probably going to come after you, the operator of this bot, before they're going to knock on the door of a bunch of other people. And so that's where we think a stack like ours is also very interesting, because effectively it starts looking much closer to what a blockchain looks like, right? You have a stack which encodes some business logic, and then you have a bunch of agent operators who run effectively like nodes of that stack, which collectively implement the actions, right? So there's no longer a single centralized actor, which I'm not a lawyer, but to us that seems very appealing in terms of the implications it has on the liability of the operators as well.
That's a really great point, actually. Like, I think people really don't think about that enough in the DAO space, liabilities and, people making decisions. And if it's just one person, it's still unclear, especially from regulation wise, what is the meaning of centralization and decentralization, especially with decision making. So I want to sort of like take it in that direction now. So I've got sort of 2 questions that are somewhat related. So of course, as you have these agents, you need to accumulate a lot of data to make sure, this machine's learning in the best way and you're training it well. So the first sort of question is, are you using any sort of data protocols for this, like the graph or Covalent? And then that also leads into another thing, which is like, let's say you've got all this data and you're making these decisions and you are in the governance, for example, so you're making data-driven decisions. So how exactly is governance sort of impacted from these data-driven decisions? And also, where's the data coming from?
Sorry, I've lost my tab. Yeah, there are 2 great questions. I'll take the first one and then I'll let Oak handle the second. So great protocols you mentioned. Effectively, every decision-making requires data, right? And so either that data has been produced as part of prior decision-making in that application, or it has to come from externally. And when it comes from external, then the question is, about the validity of the data and the accuracy of it. And so that's why effectively any decision-making problem at the heart of it has a bit like this Oracle problem, which we know from blockchain, in the sense that you need to get this data in and you need to ensure that validity. And that's why actually we've built the Oracle first, which was mentioned already. So all our services, effectively, the way it works is that they can, either talk to external APIs like the Graph or something like POC Network to get a sense of what the on-chain state is, or directly talk to a node, their own or multiple, ideally, to establish the data in the first place and then the correctness of it. That's effectively works like an oracle. You pull in the data depending on what kind of data is. Maybe you can even do some form of verification. Maybe it's signed or maybe it's not. And you basically just have to apply some statistics, like for instance, in one of our oracles right now, where we're just pulling in price data from different feeds, we apply some sensible statistics to establish whether something is an outlier or not. There's many things you can do, and the Basic framework supports you to implement whatever is more suitable for your use case. And to be honest, there's a lot of growth opportunity on the software side we see there. But what gets interesting is that a lot of services will have similar data needs, i.e. pulling in similar data, and so that's where composition becomes very interesting. So we thought very early about the composition in our stack at all levels, so software as well as the protocol, as well as on the service level. So on the software level, it means like you can compose blocks of business logic, and on the service level, it means these services can off-chain talk to each other and effectively exchange signed information. Sort of what we see there is a sort of more crypto-native way for effectively the way to think about APIs. But that's obviously an ongoing challenge, which we are not solving ourselves. It's just, we're part of the ecosystem, and I think slot in very well with these other tools you were mentioning before.
Yeah, so maybe to just extend on it a little bit, because we started talking about the Oracle. For context, it was, we released it last week. It's an Oracle which has a BTC USD price pair, and I think maybe there are one might ask the question of what it does, what's different about it in comparison to sort of other Oracle providers out there, and the answer is actually that in isolation, it's in terms of what it delivers, it's very similar. But as David was just mentioning, the real advantage comes when you sort of realize that this Oracle is actually a component which can be imported into whatever you're building. And so the Oracle is actually a Lego brick itself, which is really novel. So for example, say as a developer, you want to build like an autonomous kind of cross-chain index, like indexing protocol, for example, if an index, like creating financial asset indexes. And so you need to have a price for BTC USD to determine whether or not in any given moment you need to include BTC. So rather than either subscribing to some like relatively heavyweight Oracle out there, you could just directly pull this component into your off-chain service and have it out of the box. Then obviously you're going to need oracles and price feeds for a load of other assets. You're going to need volume scores for those assets as well. Each of those, in all likelihood, have already been built by somebody else and registered on the protocol, and so you just import them in the same way that as simple of a way as you might with npm in another environment. To take this example of composability even further, maybe you need a keeper to kind of enact changes to the whitelist for your index on chain, and a bridge to kind of autonomously move liquidity around to back your index. And all of those things can be imported from existing pre-built components and services. And so this, we see this as, really potentially being a kind of a step shift in how people build, particularly off-chain services. But this is a level of composability that we don't think we've seen anywhere else within crypto yet. All of this is, by the way, is facilitated by the kind of the structure of the on-chain protocol and the incentives there. And I'm sure we could run through that. David can run through that.
I was just about to ask about this, right? Like, I guess first of all, sounds super amazing, right? Composability at the heart enabled, right? Like all the DeFi ecosystem. So I guess you're on the right track there. And I'm also like super interested in now you have these different agents, right? Like maybe I build this index agent. It kind of pulls from that Oracle agent that someone else built. Of course, that guy maybe wants to get paid, like even the guy running the agent, but maybe also the person that builds it. I'm assuming there's some economic system there on chain that does that. So I'm super curious to hear how that is implemented, what roles are there maybe exactly, and I guess how what are rewards and risks and things like that in that system?
Yeah, let's dive into it. So I think the first thing is we talked a lot here also about ambition. So practically in the V1, we're focused on that composability mostly on the software level. So what Oak was saying, you can take existing software pieces, reuse them in the service you're creating, and then at sort of the time after, we're kind of going to focus more on making cross-service communication a thing and tackle the economic incentive challenges which arise there, right? So I would pause that for the moment and focus on what the V1 delivers. So there we very much focus on getting started, right? So we basically see there effectively on the developer side this kind of unfortunate situation where we have, on-chain this huge amount of reuse and forking, and that has generally positive implication for the space. But then off-chain, there isn't really a substrate on which people really build and reuse things. So everyone has probably quite horrible code running somewhere, which is whacked together very quickly in some cases. And so how do you enable that reuse and composability? That's what we're focused on with step one. So the initial protocol has two purposes. One is securing the service. So let me just kind of get this out of the way because it's important, and then we'll focus on the incentives, which is the second part. So securing the service is made up of agents, as I said before. So let's say there's 4 agents, just for simplicity, can be many, many more. Now they would effectively form, for lack of a better word, a multisig. So imagine you're like 4 people, 3 of you are enough for signing. That would be your service. There's 4 software agents, 3 of them are enough for signing. They, off-chain, always agree on what they want to do next using some form of consensus algorithm. And then they submit a transaction to the chain, which arrives at our protocol, gets verified that the correct agents and a threshold of them signed that transaction, and then acts upon the underlying third-party protocol. Let's say moves funds into Uniswap, let's say, or does whatever, right? Now that design means that the agents themselves basically don't hold the funds. It's an on-chain smart contract wallet effectively, which holds the funds, and that gives you a lot of security. And our protocol basically brings, all that together with kind of registering the agent, registering the service, all this machinery, all this ops concerns around how do I even spin this up, the stages of spinning this up, all this kind of delivers our protocol. It secures them therefore. There's also an element of slashing, but let's not maybe dive into that. So on the other side, there's incentives. We are very interested in basically finding a way to reward developers who contribute pieces into the system. And that's where the other part of the protocol focuses on. So we are probably not ready to divulge all the details because we're a bit too far from launch. But roughly speaking, the way it works is that a developer contributes either an entire agent or subcomponents of agents. And if those agents find profitable application in the wider services ecosystem, then there's a way for them to see a reward.
Great. Yeah, I think that makes total sense until you sort of get a bit closer to fully launching, to completely, even yourselves, understanding the types of incentives you can include for these engineers that are doing great work and contributing to your protocol in ways that probably we can't even imagine yet. I wanted to ask a question on, I guess, Chorus One, we're a node operator. So, are there node operators on your network? Are there any amount of node operators that you're looking for? Like, what's the type of work that a node operator might do on your network?
Yeah, it's a great question. So the roles we have are the service owner. So that's the entity responsible for coordinating the service. There's the developer who contributes the code, and then there's the operator who runs an agent. And that latter piece, let's pick this apart. So what effectively happens as an operator, you'd be looking at running a predefined system, right? So the service operator will have already defined these are the agents, that's their configuration, that's referenced on chain in the form of hashes effectively of the off-chain code and configuration. And so what the operator then gets from us is effectively a CLI or SDK a CLI basically where you can point to that service which you want to operate, and it sort of feels a bit like a one-click thing. So we're working very much towards making it as straightforward as the operator to basically just point at the service on chain, and then it will spin up the agent. The agents then have these kind of phase where they need to find each other, they need to establish their network over which they do the consensus and so on and so forth. So it's all quite involved, but that's all sort of abstracted away from the operator. So the operator ultimately has to make a choice as to what service they want to operate in and then bid for a slot in one of those services. To begin with, it's kind of pretty manual. So in the next the onboarding process for the operators in the next few months, basically we are working with select operators who want to run a bunch of agents for one of our services, and then we basically kind of let them into that service on chain. Then we give them access to that CLI tool, and then they can run it. But over time, certainly when the protocol launches, we want that to be basically just accessible tooling and sort of work out of the box.
All right, cool. And then I guess you were saying there's kind of a marketplace, so the node operators also to some extent compete on who will get to run the agent, or is that also like something that the service owner might like determine, like maybe kind of how he chooses his operators, or how is there like one system in place there or multiple ways to run?
Yeah, it's a great question. Yeah, we want it to be ultimately a marketplace. So in fact, the vision we have is full autonomy. So the option for one autonomous service to launch another autonomous service. That's the dream, sort of the benevolent Skynet in a sense. Initially it's again all staged. So initially it's very manual. The service owner advertises to the operator. So that's until protocol launch. Then with protocol launch, the initial setup is first come, first serve. So there isn't a proper market implemented. And then as soon as we have capacity to worry about, building a marketplace, then we'll kind of extend that on that side to effectively have like probably a bidding kind of scenario or something. I mean, we want to work with people like you as well to actually figure out what's the right way of doing this. So first come, first serve right now seems like the obvious thing, because in a sense, it's not like there's, 500 operator queuing up for every of those services. So I guess like in the beginning, it's mostly the service owner having to advertise to the operator that this is actually ready now to be operated in a sense.
No, definitely looking forward to working with you, your team on that, and giving feedback on that design for sure in the future as you get closer to going live. And just on that topic of going live, maybe to round up as a final question. So we've spoken a little bit already about your go-to-market, like including the academy, which I think is really interesting. And I think, it'd be fantastic if one of you could elaborate on, what the academy is, how it's part of your go-to-market, and where to from here.
Yeah, absolutely. So the academy, we're actually coming up to just closing our third cohort of the academy. Basically, the aim of the academy is to sort of seed the early developer community, handhold people through the process of getting set up, and all the while kind of improving the stack based on their feedback, and also kind of kickstarting the flywheel by having them build like real applications. And as I said before, the El Collector, which will be out before long, is an example of that. But then there's also another one which we can't talk about here, but that will be following up before too long as well. So it's already kind of yielded some very interesting results. Yeah, so I mean, just to kind of quickly tell the audience about it, because I suspect there are a few people who might be interested. It runs around 4 to 6 weeks, runs about once a month. It's 8 to 10 hours of kind of part-time input a week, with like part lectures and part sort of guided practical work, all in a small group, because we really want to focus on the people that we select to join it. It's instructed by partly by David here, but largely by 8baller, who's sort of the archetypal agent developer, bit of a legend. So why participate? I feel like a lot of people are trying to get into Web3. A lot of them with solid Python skills. I think we've mentioned that the stack is you basically build these services in Python. So it's like really a great fast track in for people with those skills. We see this as we see these autonomous services as a big part of the future. So it's sort of a future proofing of a developer's skill set. Whatever you work on will eventually go live on the network, and could be a core piece as the network grows and it gets imported and used in other services. It's a great way to build people's profiles, et cetera, et cetera. Basically we're looking for people who are either breaking into crypto or in crypto and recognize the problems that we're talking about and want to be a part of fixing them. People with pretty strong Python skills, so either kind of engineers or data scientists. We've had great feedback from the people who've gone through. Some say it's the coolest tech they've ever worked with. It's a great challenge. You meet a bunch of other very cool people, and ultimately will lead on to we think many other opportunities within the space. So we'll hopefully get a link in the show notes for people to come and apply.
Yeah, for sure. Thanks for that pitch. And I guess in general, thanks both of you for coming on. I think maybe like final words, you can pitch a little bit one last time, and kind of tell us where people can find you guys, and also like Autonolas on socials or website and so on.
Yeah, I mean, we're obviously super passionate about this idea of putting an autonomous service into the heart of the operations of every DAO. We have some services which are nearly up and running. Obviously the Oracle is up and running, but some which are nearing completion, like the El Collector. So we'd love to speak to collector DAOs about that. We have a yield service, which is on good track, and we're looking for early partners for people who want to either put it in their DAO, or DAO frameworks who want to make it available to their DAOs as kind of a good way to manage their treasury. But yeah, apart from that, you can follow us on Twitter at Autonolas, or you can follow David at David_Enim, ENIM, and you can follow me at Tanned Oaksprout. So yeah, that's us.
Yeah, thank you very much for that.
Yeah, I just wanted to say as well that I've been a huge fan of Chorus One, but actually even before Chorus One, sort of Epicenter and like Brian and Maher's work on Epicenter kind of followed through by you guys at Chorus One. So yeah, it's been great to actually be on the show with you.
No, it's been fantastic to host both of you, David and Oak, and we're sure to bump into each other in future, and we're really happy that you came on the show today to describe to the world what you're building, which is so unique and really exciting. And I think the tagline of like putting the autonomous and decentralized autonomous organization is like a great tagline, and one that actually Philip Guterin himself has talked about in the past. So really exciting, and we can't wait to see you guys go to market and go live, and look forward to working closely with you in the future. So thanks for coming on the show, and thank you.